Hey guys, I hope you're doing well. I just want to say before we get started on this lesson, if you have any questions, it's really essential that you ask them of me, and it's ideally during our class time. I've got lots of time during that where you can ask questions about any lesson. This format where we kind of do this flipped classroom type thing where you're watching video lessons, especially since we can't ask questions in class, this only works if you ask questions of me at some point. It can be by email, it can be through the video chat, it doesn't matter as long as you're able to clarify any problems you might have. So I just want to say that before we get started. So here's the warm-up for lesson 5. You can try it out yourselves. It's really just review from the last class. I'll just walk through it a little bit. You've got, if we look at 1A here, finding max, min. We didn't talk a whole lot about the midline, but the midline of a function is like halfway from the max to the min. And so if you go from your max of 3 to -1, then your midline is going to be y equals 1, which is here, like that. And then the period, remember, is the length of one full cycle. So you can pick any point on your graph and then just follow it along until you get one full cycle. So in that case, this one's 4. And then your amplitude, you might remember, is your max minus the min divided by 2. So in this one, we get a value of 2. And you can look over the next one on B, just to walk you through. I put approximately here for max and min because it's not exactly on the 2. It looks more like 1.75 roughly. And you can go through that. So then you can do these number 2 here where you've got the function at certain x values. Just watch with D. After you've tried this, you can listen to this, but because we're at f at 33, that's way beyond where the graph is. What we have to do is use the period, and so the period length is 4, and because everything just repeats itself, I took 4 times, and I said 8, you could use 7, you could use 6 maybe even, but you have to do 4 times a certain number in order to get back onto the graph where you can see a point, which ultimately what I got was f at 33 minus 32, which becomes f at 1. And then if you actually go to the graph, f at 1 is here. So f at 1 is equal to 1. That's the y value when x equals 1. So just a little thing you have to watch out for there. Okay, let's get into today's lesson. So now we're going to look at graphing sine and cosine and eventually tangent. And it's not too complex, and a lot of it's going to follow what we did with transformations of functions from earlier in the year. So it's kind of a good review of that stuff, although some things are slightly different, of course. So what I'd like you to do is to use this table of value here on the left side, and I want you to try to graph y equals sine of theta. And so you can use your calculator to punch these values in, and once you use these values, these are all those special cases. So sine of 0, I would punch that in, and I get a value of 0 for y. Sine of 90, and I get a value of 1. 180 is 0, then 270, I'm all the way down to -1, and 360 returns to 0. So what I'm going to do is plot those. So I've got the point where x is theta. So the x-axis is theta. So I've got, this is where my function for sine starts at 0, 0. And then it moves up to 1 by the time I get to 90 degrees. And if you remember, sine of 30 actually is right here. And so this would be 30 degrees, it would be 0.5. You don't necessarily need that point, but it kind of gives you an idea where those things are. So all of the values that we have plotted or used before, sine of 30, sine of 60, all would fit in on this curve. So the next one here, the key point is 180. And so again, if I was to do sine of 150, that's the same as sine of 30. And it would be that point there at 1/2. And if I continue on, I'm just going to plot the rest of the key points. 270 is -1, and 360, I get to 0. So what we do is create a nice curve here that goes and connects these points. And those 5 points over here on the right are the key points for sine. And you're going to need to know them, but they're not hard to remember because you're just moving up for x or theta, whatever you want to call it, by 90. So you're jumping 90 or adding 90 each time. And then these values, you can hopefully remember them, but if you can't, you can always just punch this into your calculator to get it. So if I wanted to graph another cycle of this, I would basically copy what I have here and put it back 360 degrees. So like this point, 0, 0, would be the same point as 360 degrees less. So it would be here at minus 360. This point, which was 90, I would go 360 degrees left, and it would be negative 270. And so this pattern is the exact same pattern as we have. And so you have the exact same shape repeated. And that's what sine looks like. And that's a periodic function. And sine is used to model a whole bunch of different things, mainly energy and things that occur in waves like this. And we'll be able to manipulate this and do a bunch of stuff to it. So before we get to cosine, we're just going to identify some major parts of this. So besides the key points, we have the maximum, so our highest value for y, so that's obviously 1. Our minimum is negative 1. The midline is just y equals 0, so that's the middle part of the graph. The amplitude is max minus min divided by 2, so 1 minus minus 1 divided by 2 is just 1. So the amplitude of sine without any change is 1. And then our period length, the length of one cycle, is 360 degrees, like that. And so if we move on to cosine, so cosine is going to be very similar. We're going to use same x values to plug in. Only now, instead of starting at 0, 0, we'll plug in cosine of 0, you get the value of 1. So we actually start up here. Then cosine of 90 goes down to 0, and you can plug these all in. And by 360, we end up at the same point that we were as 0. So I plot this in like this, and I get one full cycle of cosine. So again, this looks pretty similar to sine, only it's kind of like this section right here. Right like that. And so cosine, aptly named cosine, is obviously related. And so if I repeat this cycle just to get a second cycle in, again, moving everything back 360, or you can just follow the pattern. This is what I get. And so cosine is really the same as sine, except, and you can write this in, cos theta is sine theta, only it's been shifted 90 degrees to the left. And so if you look at it, this point here, if I go back up to sine, so I'll just highlight it maybe in green. So this point here is the same point as this. And so cosine has been shifted, and this point, which was 0 here, is now shifted over here 90 degrees. And so they look really similar. So again, these are going to be the key points, though, that you're going to have to know for cosine. And if we figure out the max and min and stuff, it's actually the same for max and min. My midline's the same, my amplitude is the same, and my period is also the same. Great. So obviously it'll get a bit more complex than that, but that's the two base functions for sine and cosine. And so now what we're going to see is all of those things that we did before. Remember when we had y equals, if we use function notation, f at k x minus d plus c. Those things, those values represent the same kind of transformations, only with sine and cosine. Only we change a little bit what we call these things. So they still do the same things like shifting up, stretching, and whatnot, but we're going to call them different things. And so a value that is in front is the amplitude. So the value that is in front of sine or cosine gets this name, the amplitude, because it's the vertical. And if you remember what I was talking about with music, if you have an amp that amplifies something, it's the vertical change in the expression of the sine or cosine. And so this is a vertical stretch or compression. And I put around here the absolute value because sometimes A can be negative, but we don't want the negative. And this bars on here represents the absolute value, which really means always positive. So if A happens to be negative, just change it to a positive when you're talking about the amplitude. So an amplitude will always be represented by a positive number. Next one is the D. So D here, and this is what shifts left, right. Always in the opposite way. So if it's minus, it's actually going to shift it positive. And it gets a special name called the phase shift. So that's just the horizontal shift left and right. Vertical shift does not get a special name for whatever reason, and it's just called the vertical shift, which is just going up and down directly as you see it. If it's positive, it goes up. If it's negative, it goes down. And then the period is something we'll talk about more next class, but it's really an expression and you have to calculate it. It takes 360 degrees and then it divides by whatever the K is. So it's similar to what we had. So here's my K. I would put it in like that. For now, we're just going to have functions that have periods of 360, but this is, again, would be the horizontal stretch or compression, like that. And so just a few other things. The midline is always going to be represented by whatever C is. So wherever it's been shifted, if there is no shift up or down, then it's just 0. The maximum and minimum, if we think of the max and min, if we go back here, the max and min for both of these were just 1. And so if I think of how transformations happen, what I'm going to do is I'm going to take 1 or negative 1, and I'm going to multiply it by the things that are going to add to it, the things like A and C. And so what I have to do is take the absolute value of A, and then I add the C value. And that gives me the maximum. And then the minimum, I take the negative version of A, or the absolute value of A, and then I add C. So basically you're taking 1 or negative 1 and multiplying it by A and then adding C. And the domain in these things, if we were using X for our angle, then it's just all real numbers. It continues on forever. And then my range, a bit more complex, it's all real numbers, but it's going to go from whatever my max or min is, let's just use -1 for now, between -1 and 1. Great. Okay, let's try this out and hopefully these things will come back to you. So first thing we're going to do is we're going to identify within a function the amplitude and period and whatnot. So I've got this function, and so my amplitude is always going to be the absolute value of A. In this case, A is -1. So I'm going to write it with the absolute value. And what the absolute value bars do, when I apply them, I just change this and it becomes +1. That's basically what it does. So the amplitude would just be 1. My period is always going to be 360 divided by K. Notice there is no K, it's just 1 here. So it's just 360. My phase shift, I'm moving right 60 degrees. My vertical shift is going up +1. And then my max and min, again, we take A, or the absolute value of A. I'll just rewrite it, plus C. So in this case, my A is -1. My C is also 1. So this becomes 1 + 1, which is 2. And then for my minimum, it's the negative of A plus C. This time, I've got negative of -1. So the absolute value makes it negative, or makes it +1, but then there's a negative there, so it becomes negative. So I get -1 + 1, which is 0. So I know that seems like a bit more complex than it needs to be. Really, this is just going to be -1 + 1. And if you want to think of it that way, you can. Okay, so in order to graph this, and I've kind of taken up a bit more space than I wanted to, but what we're going to do is take the key points for sine. So if you go back to the beginning here, these are my key points, these 5 key points. So I'm going to take them, I'm going to do it down here just because I get a bit more space. So I'm going to make my table of values. So I'm going to take those key points, they start at 0 and they go up by 90s for x, like that. And my y values, you'll start to remember, but these are them, like this. So now what I want to do is I want to apply the transformations just like we did before when we were dealing with any function. So the x value, I'm going to change these. So it's going to become x, and we're adding 60 to it. And that's the phase shift. So that's this guy here, plus 60. So that's what I'm going to do to my x values. And then I think about what applies to the y's. And remember we had, if we did this in a little, this would be x over k, and then plus or minus d, however you want to think of it. And then my y values would be ay plus c. So my a in this case is -1. So I'm going to say negative y, or -1y, and then plus c is +1. So again, that comes from these here in my equation. So we're going to take those key points and apply these transformations. So let's do that to these. So I'll just deal with the x values first. 0 plus 60 becomes 60. This one becomes plus 60, so that's 150. 240, 330, and then we're going to actually be off the graph, but that's okay, and then 420. So my y values, I'm going to take each of these y values and I'm going to multiply by -1 and then add 1. So 0 times -1 is 0, plus 1 becomes 1. And then 1 times -1 is -1, and then plus 1 is 0. So you can go through this process. Then that one repeats, and then I'm at -1. So I get negative of a -1, which is +1, then I add 1, so that's 2. So that's where I reach my max, and then the last one returns to 1. So first let's plot the original function just to compare it. So here's my sine graph. Like that. And I'm going to repeat those over here. And so for now, all of these steps are going to be 90 degrees between each of the points for the x. So that's helpful. So this is y equals sine x. And now let's plot the transformed function. So I'm going to take these points, so 60 and 1. So each tick represents 30. So starting here, and then 150 and 0. So 150 would be here and 0. And then 240 and 1. And then 330 and 2. So something like that. So notice I didn't even get one full cycle in. What I can do is that I can extend it to the left. So if I do that, I've got to go back 90 degrees from this, and I'm going to reach the same height as this point, the 2 over here. So that means I'm going to be right about here. So 30, 60, 90, like that. And there's one full cycle. So now the trick is to complete this. So if I do that, going back 30, or 90 rather, I'm here, then here, here, and again off the graph. And there's my graph. So that's the easiest way to graph this. And I know it seems a bit complex at the beginning, but I'm sure you'll definitely get this as we go through. And we'll do a bunch of practice before you have to do it on your own. Okay, let's try this one. So again, identifying everything here. So I've got amplitude is my A value. So it's just +3. Period, we are not changing it. So that's just 360. The phase shift hasn't moved at all. My vertical shift is up 1. So my max will be 3 plus 1, A plus C, so that's 4. And then the next one's going to be -1 times 3 plus 1, which gives me -2. So this one's been stretched out by a factor of 3. So again, I've got more room, so I'll do this here. So I'm going to do my key points. Now it's the key points for cosine. So my key points for cosine, still 0, 90, and so on. Except for now my y value starts at 0. So the cosine of 0 is 1, cosine of 90 is 0, cosine of negative 180, and so on, like that. So this is the part that's key that you're able to do, is to get the little algorithm for x and y. So in this one, notice there is no k value and there is no phase shift, so my x stays the same. But my y value I'm going to multiply by 3, so that's a, plus the c value. So these are the transformations I'm going to do. So I'll just write in the x's because they're not changing. And then we'll do the y's. So the y's, I'm going to take each of these and multiply by 3 and add 1. So this one's going to be 3 times 1 plus 1, so that's 4. 3 times 0 is 0, plus 1 is 1, and so on. So 3 times negative 1 is negative 3, plus 1 becomes negative 2. Then I return to that one, which we already did, and then this one was 4. So if we plot these, let's start with the cosine function. So there's one cycle, like that. So that's y equals cos x. And doing the transform one, so this is, we're all the way up to 4, 90's at 1, and we're down to negative 2, 1, and back up. So I try to make it a curve here. So I continue this pattern. Oops. Like that. All right. So that's the process. Take those key points for sine or cosine and then see if you can transform them. So what I'd like you to do is to use this as a guide 100%, but see if you can try these. Okay, let's go through these ones. So hopefully you've tried this on your own. If you haven't, please do that. So I'm just going to fill this in. I've got amplitude, period, phase shift minus 60. So I changed the sign. Vertical shift, we're not doing anything. And so my max is just 4 and my min is just negative 4 because that's the amplitude. There is no vertical shift. So I'm going to take sine key points. So 0, 90, 180, and so on. And again, the key part here is to be able to do this. So I'm going to do x minus 60. I'm just going to move that over. And then y times 4, because that's my amplitude. So this is going to become negative 60. This will be 30, 120, 210, and 300. And then my y values times 4. Like that. Okay, so I'm just going to graph the transformed one, but you can graph both if you want. So there's one cycle. So that's going to continue on. If I continue on the left side, so every 90, and there's my transformed one. Like that. Let's try the next one. My amplitude here, remember, it's the absolute value of the A value, so this is 1. So my amplitude's always positive. Phase shift is minus 150. Again, no vertical shift in this one. My max would be 1 because the only thing applying has been flipped upside down. So I'm just going to have the absolute value of negative 1, which is 1. And then my minimum is just -1. So again, start with my key points for cosine. This is cos. X value is the same for both cosine and sine, but y values change. This is 1, 0, -1, 0, 1. So now I'm going to subtract 150 from my x. And the y value I'm going to multiply by a negative. So it's going to flip it upside down. So this one becomes -1, 0, 1, 0, -1. So if we go ahead and plot that, so there's one cycle. I'm just going to continue on in the pattern. And there's our graph. Great. Okay, the next couple, a little bit trickier, but not too bad. So again, amplitude 3, period 360, because we're not changing it. Phase shift plus 120. Vertical shift again, now -1. And then my max, remember it's going to be whatever my A is, only the positive of that. So 3 and then -1, so that becomes 2. And then my minimum is going to be the -3 minus 1, which is -4. And we'll always see that once we do these key points. And then my transformation, so it's going to create something where I've got x plus 120. And the y is times 3 and then -1. So I'll add 120 to each of these. So I'm going to get values that are way off the graph, but that's okay. We'll figure it out once we get graphing. So my y values. There's my minimum. Okay, so let's plot this. So 120 is my first point. So notice we only get part of the graph. I'm going to continue because I guess 390 we kind of can get on. That's -4 down here. Like that. So you have to remember this is going to repeat. So getting that one on the right actually is kind of helpful. So this one is going to be down here as well because that completes one cycle. Like that. And so the next one, if I continue over 90 degrees over, so that gets him there, and then another 90, and you just follow the pattern. Like that. There we go. Okay, one more. So amplitude 2, period 360, phase shift plus 90, vertical shift plus 2. My max is going to be A value and then plus the C. So that's going to be 2 plus 2, which is 4, and then -2 plus 2, which is 0. This one's cosine. So we start at 1, remember, and then 0, -1, 0, and 1. And now we're going to do x plus 90. And my y values as times 2 and then adding 2. Great. So you can put all those in. Double check that you got those right. So my y values, I got 1 times 2 plus 2, so that's 4. There's my max. Then I got 0 plus 2, so that's 2. 270 is going to be 0. Then I return to the max. So let's plot that one in. So again, this is going to go over 90. So there we get one pattern. Notice it's cosine, but the actual graph looks pretty much like sine because it's been shifted to the right 90. So if I continue that pattern, and there we go. So the key to this is just practice, but go through it. I'll post the solutions to your work. So there's not a ton to do here. It's just really practicing stuff and then some graphing questions down here, but I'll post those